We'll now look at an introduction to what's known as hypothesis testing. The idea being we are going to make some kind of claim or conjecture about a parameter, and we're going to see if it's true or not. And it may or may not be true, and we'll do some testing to figure out whether or not it is. And there are two types of hypotheses. The first is called a null hypothesis. It's denoted by this H0. And the null hypothesis says there's no difference between the parameter and a specific value. As an example, the null hypothesis should look something like mu is equal to 4.3 or p equal to 70%. We are assuming that the mean is equal to exactly 4.3, or the population percentage is 70%. On the other hand, we have what's called the alternative hypothesis. And it's denoted by H1. And it says that there is a difference between a parameter and a specified value. There are three different options for the alternative hypothesis: a greater than, a less than, or a not equal to. So maybe we have an alternative hypothesis that says the population mean is greater than 4.3, or the population percentage is less than 70%. Or another example, we just want to know, is the mean 27 or is it not 27, whether it's higher or lower. Let's look at a couple of examples of trying to figure out exactly what our hypotheses should be. So let's suppose that we have a particular researcher that thinks that smoking is going to cause the birth weight of a baby to decrease. So this is an old study that we did many years ago, but essentially we want to say that a pregnant mother smoking will reduce the weight of the baby. And let's suppose that we know that the average birth weight of a baby is 8.6 pounds. This would be our null hypothesis. It is exactly what we think it is. The alternative hypothesis, since we think that smoking is going to cause the weight to drop, we would say the mean is less than 8.6. It's going down. As another example, let's suppose that we are in a manufacturing process and we're manufacturing something like calculators. And we're testing for defects. And we find that on average every day, this particular place gives 5 defective calculators. So the mean defective calculators per day is 5. And we want to know, is that accurate? Is it actually 5? Then the alternative hypothesis would be it's not 5. So someone's claiming it's 5 and we want to test, is it 5 or is it not? Another example, let's suppose that we're taking a test and we know that in general 50% of people pass this test. So the proportion that passes is 50%. And we think that playing soft music like classical music during this test will increase the results. It'll cause a greater percentage to pass. So we would have p greater than 0.50.